Okay, we got this problem here with, and I set this over to the side here somewhere, this guy traveling through the desert. Now, before I start up with this, I'm going to say heads up, you're about to see the super complicated way of doing this, so just beware. Aside from that, you could always use some guess and check, and I'll give you some guidance on how to do the guess and check, but I would recommend that you kind of just try this out on your own before you watch this video. I don't want you to get confused by what you see here. All right, so the question is, Alex is up here in the desert. This is all desert out here, except for this is a road right here. And Alex has to get to this gas station. He has two options. Well, he has lots of options, right? But two options. First, he could drive straight down to the road through the desert and then turn and drive down the road. So through the desert, straight to the road, then down to the gas station. Or he could just kind of cut through the desert right there. Okay. And our first question is, well, which one of those would be better, considering the fact that he can drive only 15 miles per hour in the desert, but he can drive 30 miles per hour once he gets to the road. Well, let's take a look. See, 6 miles at 15 miles per hour would be, let's see, 6 divided by 15 would give us, let's see, that's 2 fifths, which is 0.4 hours. We'll worry about that is in minutes later on. And then you have to drive this 13 miles divided by 30 miles per hour. Let's see. Clear 13 divided by 30. And we're going to actually put that as a decimal, 0.4. So that's 0.43. We'll round it off for this, hours. So total is 0.83 hours approximately. So let's see what happens if he drives like straight through the desert. Now first we got to figure out how far that is. So let's see, that's going to be a squared, b squared, c squared, 6 squared, 13 squared, c squared, 36, 169, c squared. At 170, that'd be 206, 205 equals c squared. So square root of 205 is c. So this part here is going to be square root of 205. So this is, so by the way, this was our straight to the road method. And over here is going to be our straight to the station. So square root of 205, let's see, divided by the 15 miles per hour, because that's how fast he goes through the whole entire thing. So let's see here. Second square root 205 divided by 15 gives us 0.95. We'll just round it off. 0.95 hours to get there. So pretty clearly, driving straight through the desert is going to save him a little bit of time. Right? But then the next question is it possible that there's some time kind of in between? There's some place in between where he could head to. So maybe like he would drive, you know, down here. Maybe he drives to this angle, 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8, 9. So maybe he drives to this point that's 4 miles away, and then he's through the desert, and then he does the additional 9 miles on the road. Maybe that works out better. We don't know. Okay. So here's where you could just guess and check. You could try it out, see what happens for 4. Try it out, see what happens for 3. Try it 2, 1, 5. Try them all out, right? And see if you can find some type of a pattern. We've done things like this before. But of course, as usual, there is a way that we can kind of calculate this precisely. So I would say that he's got to travel this part right here. Okay? And no matter where this is always going to be this hypotenuse with 6 on one side, and we're just going to call this x. Okay? So we've got this distance being.
I got candy for you.
Okay, I'm in the middle of something, but just be a second. Have a seat. Let's see. We've got 36 plus x squared right there. And then this remaining distance after we take x away would just be 13 minus x. And we can travel this portion at 15 miles per hour and this portion at 30 miles per hour. So our equation would be the square root of 36 plus x squared over 15 plus, let's see, 13 minus x over 30 equals our time. So time spent traveling through the desert plus time spent on the road equals total time. And then we'd have to figure out what sort of outputs this function gives us. And here's where it gets super complicated. If we go over here, we find it. Here's a graph of that function. And here would be the 0 would be if we traveled straight down to the road. All right, and that point right there, see if we can find it there. I'll place a point there. Let's see, let me find my point tool. Here. So you can put a point right there. Okay. So you can see here at 0, that was 0.83 right there. And that's, that is where if we drive straight through the desert, let's go back to our graph here. If we drive straight through the desert to the road, we got 0.83. And we go back here. If we drove all the way to the 13, so let's go find that. We'll place another point there. Here's 13, right there. So 0.95. So if we drive straight to the gas station, which is 13 miles out, it takes 0.95 hours. Let's go look at that on our graph. Here it is. Right here. So if we drive all the way out to the 13-mile mark, we got 0.95 hours. So then, and this is super complicated, and I didn't even feel like doing it by hand, to find the minimum value of this function. So I just let the algebra system do it for us. It's right here at 3.46. And at that point, it takes 0.78 hours to get there, which means that if we drive right around 3.5, right there, a little bit off from our 4, which is our initial guess. So if we were to drive straight from where he is down to that point, then turn onto the road and head down to the gas station, that'd be our minimum value. It's not something that really I would expect any of us to do to figure that out. Rather, we'd have to go through like a guess and check sort of system, trying out different values of x and seeing what happens.